Yep, hello. Just a few words about me before we start. So I'm Olivier. I'm originally from Belgium, but now I live in Berlin. And I started contributing to open source and developing by taking care of the KDE community. So I joined the KDE project, and that led me to work also on Qt in the Qt community. Then when Rust came along, I was a bit curious. I thought, what's this new language? It looks very good, so I thought I need to try it out. And one thing I did is to try to integrate QML, so this Qt thing with, so making Rust binding for Qt basically. So that's why I wrote this Qmet object Rust create, which is bindings for QML. But then a bit later, I founded Slint, which is a UI toolkit totally written in Rust. More on that later. So this talk is about Rust macros. So I want in this talk to give you a bit of how we use macros inside of Slint for the Slint macro itself, which is a domain-specific language in Rust. And maybe it gives you some idea of what you can do, what's possible, and things like this. So let's start with declarative macros. This is the first macro that exists in Rust. It's there since Rust 1.0, and this has the advantage that you just put it somewhere in your crate. You have this macro. It can simplify a bit some boilerplate. So let's see one example of how we do it in what we do in Slint. For example, we want to declare some enums that are used in the Slint language. We want to declare it in a global place, and it can be then used by the runtime library need those enums. We need to map that to the Slint language and things like this. So what we do in a common crate, we don't declare the enum, but we declare a macro that we call for each enums. And this macro is a bit special because basically you call it with another macro, but you don't put the exclamation mark at the end. The exclamation mark is there. So the only thing that this macro does is calling your macro, and then in that macro, it puts all the enums. So then that means that in the runtime library, we can then use that macro, this for each macro, and what we can pass this a declare macro enum that will then for each enums will declare the enum and add a bunch of common things that all those enums will have. Then we can reuse it. So in this case, for example, we also have a C++ API, so we also generate header file with those enums. We integrate that we generate the documentation also from this macro, everything with one macro that declares everything. Another thing that we do, I don't have stats for this, but we also declare all the nodes of our language for the parsing. It's all declared in a big macro like this. So that simplifies a lot of the boilerplate that we would need all of us to repeat for every single node. So we just have a macro, in declarative macro that does that. And declarative macro is fine for that because we just take some code, so just a list of things to expand to more things, which is the same for everything. But you can do a lot with macro. So with declarative macro, you can do a lot. It's very powerful still, but it gets really complicated to do the parsing and things like this. So one thing that you can read, and I recommend, is this little book of Rust macros. There is a URL there, and that explains like how you can leverage declarative macro. So let's get to the meat of the topic, which is the procedural macro. So procedural macro is a function that is actually called at compile time by the compiler. And this function takes as parameter a token stream, which is basically a list of tokens, and return another token stream, which is also a list of tokens. And tokens, you know, maybe the word from LLMs or something like this, is just kind of word or unit of things in the language. So identifier or strings or numbers or things like this. So for example, in this my macros, those tokens will be some tokens. And you can have either function like macro, which is written like with an exclamation mark, or you can have attribute macro. In this case, you have like two lists of tokens, the attribute, in this case, some attributes, and then the items that follows. Or you can have also derive macro, which then adds more token to the things. Derive macro was introduced in Rust 1.15, And then only like 2 years afterwards was the other procedural macro in 1.30 introduced. And so that means that for a long time, it was only possible to do procedural macro with derive macro. So that's relevant because when I did this meta object, this QML bindings, there was only derive macro. So we were trying to put everything into a derive macro using some hacks. But thankfully, this is no longer necessary because of the powerful of the normal procedural macro. So for a procedural macro, you need an extra crate. So this is a bit annoying because you need at least 2 crates, one for the runtime, one for the actual macro. And you also will most likely need all of those, have a bunch of extra dependencies. So let's go over those dependencies and find out what those dependencies are. So there is the first is proc macro 2. So this crate just replicates the API of the proc macro built-in crate. And this proc macro built-in crate is just contains a way to work with the token stream. So it has like the class like token stream and then identifier, span, and stuff like that. But why does it need to be duplicated? Why can we not just use proc macro? That's because proc macro, the built-in crate, only work inside a proc macro. But there are cases where you want to use it outside of proc macro. For example, if you want to run test, you want to give some token tree and see what if the result token tree is appropriate. This would not be a proc macro. Or if you want to use a build RS script to do something with some Rust code and use the same code in the proc macro and in build RS, you would also want to use that outside of a proc macro. So that's why there is proc macro 2. But if you're just interested in making a proc macro, you still need proc macro 2 because the other crates like Sin and Quote, they use proc macro 2 behind the scenes. So you need proc macro 2 regardless. So speaking of Sin, this is a crate that is parsing the Rust code. So what does that mean? So what you get as a token stream is basically a string of tokens. So hash, open bracket, and things like this. Not very useful. What you want really is, you could try to parse all of this yourself, but what you want is for a structure to have all the list of all the items, or for an enum to have all the variants. So that's why Sin basically takes this token stream and give you some structure in a structured way, so you can access, for example, for an enum, you can access all the variants of that enum and whether it's visible, if it's public or not, or things like this. And same for a struct, you can get all the fields of your struct in a AST, in a syntax tree, which you can operate into. So Sin is also quite heavy dependency, so that when you hear that procedural macro take a long time to compile, it's mostly because of Sin as a dependency. And yeah, this is how it is. And you might be thinking, okay, then let's not use Sin, let's use something more lightweight. That maybe there's a smaller alternative. The problem is, if you do that, then in the final project, you will probably end up with both Sin, because some other crate is using Sin, plus the other more lightweight dependency. So in the end, it's just counterproductive. So yeah, need to be careful about that. And the last crate is Quote, and Quote is just so you can write code that looks a bit like Rust code, and that just to generate the token stream based on some Rust code. Let's talk about the Slint macro. So in order to talk about the Slint macro, I first need to talk about Slint. So I'm just going to make a short introduction of Slint, which is a UI framework. And so Slint is targeted as the desktop and embedded more, so not really the web. But it all works natively without a browser. So we have a markup language, so it's a domain-specific language, which I'm going to talk about in a minute. And this markup language is compiled to Rust or C++, because we also, despite the whole project is written in Rust, so the whole runtime and compiler is written in Rust, but we expose API to many languages because we don't want to be the toolkit for Rust, we want to be the UI toolkit in general. And we are fairly lightweight, meaning that we also work on microcontrollers with like 300 kilobytes of RAM, so kilobytes, not megabytes. Just a word about the license, because it's a bit an unusual license for typical Rust crates, as we are not MIT, but we're still open source. All the development happen on GitHub. We just have like 3 licenses. The GPL, which is copyleft, meaning that all your code needs to be in a compatible license, like the GPL itself, or MIT, Apache, and things like that. Or we also have a royalty-free license, so you can do proprietary software on the desktop. So it's like a permissive license, but it's limited so that on embedded devices, for embedded devices, you need to have a pay license unless you're open source. So there's 2 ways to use Slint. The first way, which I'm going to show, is the Slint macro. So this is just a hello world. It's the complete source code of just a small example that has like just a text and a button. And as you see, you put all the code in a Slint macro, and this code will then generate a struct which you can instantiate from Rust, and you can have like it generates also some getters and some callback that you can call. If you don't like to put all your code in a Slint macro, we offer also to put your code in a Slint code, which you can build from the build.rs. So Slint is, as you saw, so this doesn't really look like Rust code. So this is called a domain-specific language, meaning that you can do basically anything into this macro. Anything, well, the code still needs to respect some Rust rules. For example, we want to have colors, and you can have red. That's okay. So here the token stream will be color colon hash, and then ff000. That's an identifier. It starts with, so it's just an identifier that starts with ff. However, when you want to have green, then that would then be 0, 0, ff. So that's no longer starting with f. So that's starting with a number. Suddenly, this is a number with, and so this is not really a valid number, because you can have, in Rust, you can have suffixes to your number. So you can have 0 EU32, for example. That would be the suffix would be EU32. Here, the suffix is ff00. It's an invalid suffix. Yet it still works, because the code that is given to the proc macro will understand that and will not generate that. It's only if you at the later pass, when actually compiling the Rust code in the parser, that it would be an error if it was still there. But it can still be the input of a macro. That is fine. However, suddenly if you have a lesser green, suddenly you get an error. Yeah, that's because now the lexer is trying to pass this as a floating point, and then and that doesn't work. So this is not a valid floating point. So at the lexing phases, you get error. So this particular error is, so we've reported the bugs a long time ago already, and actually the Rust contributor are actually going to fix this to make it valid for macro to use, this kind of things. But this is still something that one need to know, that the code cannot be anything. It still needs to lex correctly as Rust code. So the string, when you have a string, it needs to have the right, you cannot invent escape sequence and stuff like that, because it needs to be valid Rust code. Another thing is that in our language, we are basically based on, we thought to take stuff from CSS. So we wanted to have identifier that has a dash in them. So that padding left would be different than padding minus left. And this is also very difficult to do, because there is no stable API to know if an identifier and the dash are next to each other. So we are cheating a bit by using the debug representation of the span. This is a terrible hack, and I hope that we can, because there is unstable API to access this, and I hope that it's sooner or later getting stable, that we can do this kind of things. We also want to include other files from our Rust file, and we would like to include those files relative to the macro that you're writing the file. But you don't know, the span API is not really stable, so you don't know on which Rust file you are. So you can only do relative include based on the cargo2mel and not on the .rs file. So you cannot simulate the include macro, for example. So a previous presentation also mentioned the problems of reporting errors. One way to report errors is to panic, but then you get a message that says, okay, your macro panicked. Here is the message, but it doesn't really tell you where. So there is a better way. Instead of panicking, you can also generate basically code that says compile error, and you can also specify which span for this text will happen. So that means that the compiler will generate an error at the right location, so you will have it. You will have a nice error for the user to see. This is where the problem is. What about warnings? Is there a compile warning macro? Unfortunately not. As mentioned, there is unstable API for diagnostics, but right now there isn't. It's not stable. So one way that we use is to use this little trick. So we abuse the deprecated attribute, and we just generate code to generate a deprecated constant that we just use. And so you get a warning that says users deprecated warning, and then the actual text of the warning. It's not ideal, but that's one way to do it. On the other hand, if you want to report errors which are not in the Rust file, but in another file that you import, so you can import files, say you import, in the case of Slint, you can import extra Slint files, or in another macro, say you want to include some JSON and parse this, and you want to report error in the file that you just included, then what you can do, you can use some extract rate, like the annotated snippets, which is also used by Cargo, and that just generate errors that really look like the Rust C errors. And the script is just going to print them into the output and the standard out, and this is going to be shown when it compiles. Okay, so I want also to speak about when you have a domain-specific language, you still want to have good editor integration. So you still want auto-completion, you still want things like this, so that the developer has a good experience. And one way to do that is to use the language server protocol. So this is basically a way for languages to add extension to the editor. So it was developed by Microsoft for VS Code, but it works with many editors that support this. And it adds things like auto-completion, diagnostics, Hoover, and things like that. So I just want to show a little demo here. So here's Visual Studio Code with the little example that we see. So this is actually Rust code. So we have main, and here, so this is Rust Analyzer. Rust Analyzer is providing auto-completion for Rust using the language server protocol. But in the same file, we have also some Slint code in a Slint macro. And because we developed an extension, so we can download it in the extension marketplace, and this enables to have two language server protocols running at the same time. So you can, in the Slint code, you can have auto-completion for your Slint file with all the properties and things like that. So other things that, and so like all the things work, like you can rename identifier or go to definitions and things like that. For example, Rust Analyzer here provide a run, and what we provide is a show preview, which then will is running it's starting another window with the preview, so that when you can edit things and it works in real time, and you can select things. You can select things, and it tells you in the code where you are and things like that. Let's go back to the slides. So I just want to mention other macros that are used in Slint. One of them is from the CPP crate, which is also a crate I've been contributing to since I'm doing since I was doing those bindings for Qt, and Slint can also optionally use Qt for its styling on Linux. And so basically with the CPP crate, you can just embed C++ code directly into your Rust code. So the way this works is that the build.rs will scan this and figure out all the CPP macro and extract the code, put that into a CPP file, let the compiler compile it, so that the CPP macro can then call this generated function. So this is great at reducing the boilerplate. And so for example, here is how we use it in in Slint. So if, in our Slint style, when we want to generate a gradient, for example, there is like three C++ functions that we need to call. And if we were to do that without it, we would probably need to write in three places, like in the place we call a function, and then some little caller function in a CPP file, and some bridge in the middle. So the CPP create helps in this case to just have for small function that's really helpful to just put the C++ code in there, and so you don't have to do context switch while working. Then there is also the document feature create, which is a create I developed because we wanted to document all our cargo features. So in your cargo toml, we just write the documentation like so, just like you would document Rust function. Here you document the feature. And then in lib.rs, we use this document feature create, and then this is a proc macro. The proc macro will open the cargo toml, look for all the comments, see that some comment and generate a markdown based on that. And so you have the result. So the documentation can display the documentation of the feature. You might also have noticed in the last slide that we have special URL like slint colon in our documentation. And so what does this do is basically because we have an extra documentation for the Slint language and the thing which is not on docs.rs. But we want from our API documentation to link to this. And those URL, we have like the version number and things like that, which is in it. And so we want to generate those URL from a macro. So we have an attribute macro, which will look at the documentation attribute and replace all the URL by the right URL and checks that this is not a 404, that this link exists. Another example, again, looking at the documentation. So as you know that you can write your Rust test in a documentation comment. And here for the parser, we have many parse functions like parse array, parse callback connection. We have like parse expression, parse if expression, parse for expression, all of this. And what we have here is a macro that do the test that will call this, so it will look in the documentation comment, it will see what kind of code it expects, and it will pass this code to the function and see that it works. So we generate tests from an attribute macro. So we are still using many macros. It's just that we're limited in time, and I had to select a few macros that I need to show. So in conclusion, macros are very powerful, and you can do a lot of things. As a wish list for the Rust project is really that this could be a bit more polished, especially trying to stabilize what is currently still not stabilized, and also to have helpers so you would not need to have the sin and quote macro. So there is a replacement for quote in nightly, which would and so there's like it would be nice if the proc macro API would also allow to get rid of, at least for some very simple use case, like I want to have a string literal. I don't need sin to parse the whole thing. It would be nice to have proc macro to do the basics. Yes, so I think we have time for questions, and otherwise I will be around, and don't hesitate to just ask questions to me, or also via email.
Thank you so much, Olivier.